folks. Welcome to your Igor, however you say it, Frankenstein, Igor Zero tutorial recorded by yours truly. So I'm going to walk you through some data that we have for this exercise. So I like using Igor predominantly for data, whereas Mathematica, I like using it predominantly for analytical relationships, solving equations, doing fairly complicated stuff. But Igor, I think, is a fantastic data analysis program. I kind of describe it as a combination between Excel and Mathematica. So let's go ahead and get started and open up Igor. So there it is. I'm going to open it up. So make sure that you enter your serial number and activation key and all that stuff. It should be available on the Start Here page on Canvas. And so you notice right away when you open this up, you've got the data browser over here, and this is the command prompt. And on my super widescreen monitor here, that command prompt gets really big. So I kind of like to just customize my Igor environment to look something like this. Everyone is going to be a little different the way that they want to interface with it. And for you PC users out there, you're just going to have one big window with everything in it where you can minimize and maximize and so on. Okay. So this, to get you started, to get you introduced here, this is our command prompt. And right here, this is where I can start, typing in commands. But also, everything that you can do in Igor can be done either with the command prompt or by going to all of these different menus. So for example, I could say Windows New Graph or New Table or New Layout or something like that. Okay. So the first thing that I want you to do is say Windows and New Table, and you'll see this option here. Don't worry about that. Just say do it. So the programmers at Wave Metrics have a little bit of a sense of humor. Instead of saying OK on their buttons, it says do it. And instead of saying cancel, it says kill. So I love it. So here we go. We've got a table up. And what you noticed, hopefully you noticed this right away, look, some code appeared. So this is my command history. And so notice it gave us the code for a new table is just edit. So I'm just going to type edit on the command prompt and push enter. And look, I get another table. So table 0, table 1. I'm going to push edit again. Okay, and I'm going to get a third table. And I'm going to push edit again and get a fourth table. Okay, and I'll show you why I want you to do 4 tables, because I've got some data for you that we're going to play with. Okay, and that data, let's see here. I put mine on the desktop. It's the Igor Zero, and I just have it as a simple text file. Here it is. So you can see there's relative humidity probe data, and that's 3 columns. Relative humidity, voltage, and then the error in the voltage measurement. There's nanoparticle data, which is diameter, and that's diameter in nanometers. I forgot to indicate that. I'm just going to edit as we go. Diameter nanometers, and then population, and that has units with it as well for this particular measurement that I'll share with you momentarily. As we scroll down, here's kinetic data. So 3 columns of data. That's OH exposure. This is the normalized. That SQ is squalane. That's a molecule I worked with as a postdoc. So that's normalized squalane concentration, and then the error in the determination of the squalane concentration. And then finally, thermodynamic data, which is temperature in Kelvin and the constant pressure molar heat capacity. So with Igor, it works very similarly to Excel. You can just copy and paste your little hearts out. So select everything in the relative humidity data, including the column headers. And I'm going to hit Command C on my Mac or Control C for a PC user, and I'm going to select this table into not that point column, but that first column, and say Control V, and bam, look at that. It put all the data into my table as well as the header label. Sweet. So let's do that for the nanoparticle data. Okay, Control C or Command C, Control V, and beautiful diameter and population. Notice when I had that parenthesis, instead it did the underscore. That's fine. Okay. And just like in Excel, I can even double click on all these columns and it shrinks them up a little bit, so I can have some more screen real estate there. And notice on the diameter, right, you scroll all the way down, it's got all the data points in there. Okay, let's grab the kinetic data, copy paste, and then the thermodynamic data. Control C, Control V. Oops, let's see, something went wrong. So, this is a good practice. So if something goes wrong, watch what I'm going to do. I'm not going to stress. I'm just going to kill this thing. No save. And then I still have to kill the file associated with that. So I'm going to say data, kill waves, and I'm going to kill that thermodynamic data, and I'm going to start again. And notice what it allowed me to, it gave me the code for that. And I want to start again because I want it to be tab delimited. I want them to go into different data. Oh, I know what I did because I selected that thermodynamic data. So now I'm just going to select only the numbers and the column headings. Control C, Control V. Beautiful. Now I got 2 columns. So this is what we call an array of data. 2 columns with X, Y dependence. Okay. So suppose that I wasn't happy with the names of all of these things. So these columns of data in Igor are called waves. And you can see they all appeared here in the data browser. Like if you look at my, so here's CP, right? And it tells me CP has 17 rows. Well, let's see if that's true. Yep. So 0 counts, so 0 through 17. And what it also does is it generates automatically a plot of that wave versus the point number. So as I scroll through these, you can see like diameter had, 70 some odd data points, 78. Okay. And I can scroll through all of these. So they're not very useful graphs because they're not necessarily being plotted as an XY graph, but all the same, I can view the data and what's going on. Okay, so suppose I'm not happy with the name of this, like this X underscore SQ underscore N. Maybe I don't like that name. Okay, so I can go data and I can say rename, and look, here's all of those waves that we dropped in. And I'm going to select that, I'm going to push over with it, and I'm just going to get rid of that X, and I'm just going to say SQ underscore N. That's fine. It doesn't really matter as long as I know what it means. Okay. And let's see how we're doing. I've also provided for you a handy guide that I made in Mathematica, Igor 0, Introduction to Igor. And here's what we're working on: making new tables, entering data, and making new waves. So we just copy pasted the relative humidity probe data. I'm going to highlight this as I go. So we copied that. We got that in there. We got that in there, and we got that in there. So we're doing good. Let's practice entering data. Okay. So I'm going to open up a new table, and I'm going to make a new table by going Windows, New Table. So that's another option for this. And I could preload any of these waves that I have, but I'm not going to do it. I'm not going to do that. I'm going to just say do it and get a fresh new table. Okay. And I'm going to start by just putting my cursor there, and I'm going to say 1, enter 2, 3, 4, and 5. And notice by default, it automatically called that wave 0. Okay. So now I'm going to tab over and start a new column, and I'm going to say 2, 4, 6, 8, 10. And again, suppose I wasn't happy with these names, wave 0 and wave 1. Well, you saw how I can go data, rename, all right? But look, that command gave me the code. There it is. So let's give that a shot. So I'm going to say rename, and notice it turns green. It's very similar to Mathematica, where it gives you, it helps you along. And now, to me, it looks like it says rename space, and I'm going to say wave 0. That's the name I'm rewaving, comma, and I'm going to call it integers and push enter. And check that out. My table, it changed the name of that wave to integers. And it appeared on my data browser somewhere in here right there. There's the integers. Okay. So let's also rename wave 1 to odds. Okay, fantastic. There it is. All right. So let's see how we're doing on our guide. Okay. Great. Entering data. Check. Integers and evens. Rename wave 0 and wave 1 to integers and evens. Fantastic. Okay. Now, how do we make a new? I want you to do recreate the following 4 graphs all on one layout using your newfound skills. I'm going to record another video. I'm going to add another part to this video because I'm starting to lose my voice. Because there are some quirks to doing some of this data. But as you can see, that all the data that I shared for you, the nanoparticle data, the relative humidity probe data, the heat capacity data, and the kinetic data, it looks good, right? You can make some really nice looking graphs on Igor. This is super high quality, super professional. So this is what I want you to try to achieve. That's all that I'm going to ask you to do on this Igor 0. And then after this, we'll have some more exercises with this data set. So we'll keep using this data set into Igor 1. Okay? So I know I told you I'm going to stop it. I'm sorry, I'm a scatterbrain. Really, I just want to stop talking, if that's okay. So what I'm going to do is play some music, and I'll work through these 4 examples so that you can see how I'm doing stuff here. Okay? So let's go for it. What do I got queued up in the playlist? Nice. Okay, I'm going to start making some graphs. If I have just a little bit of stuff to interject, then I'll slow the music down or quiet it off so that you can hear what I'm saying. Okay, relative humidity on the Y, potential voltage on the X, RH on the Y-axis, volts on the X, Y versus X. I now have Y versus X data. Do it. Okay, with all data points, not lines. When you have a smooth function, use a line. When you have data, use data points. Play with these markers. They're super fun. All kinds of options. See? I like stroke color. data points. Three by three box. Okay, that one looks good. I'm going to do nanoparticle data now. So now I can say display. I'm just going to go back to the menu. Okay. Diameter is on the X. Population's on the Y. Notice this error because diameter and function C aren't connected. But diameter and population are connected because they have the same number of data points. Do it. 3 by 3 box. Maybe 35. Yeah, that looks good. Put the data in the middle, right? So I don't think I need that many ticks for the left axis. I don't think it's necessary. Oh yeah, okay. Here's where I do want to demonstrate some scientific notation. Okay? So let me pause this real quick. Okay, so notice it's the number 7,000, right? And I have this high trip and low trip. The high trip's at 10,000. So if I make the high trip go down to 1,000, now that number 7,000 is bigger than the high trip. So it automatically kicks over to using scientific notation. Okay? And so if I go in the axis label and call this population, and I didn't tell you this before, but the population of this nanoparticle data is technically dn per cubic centimeter. So I can say cm special style, special superscript -3, and then special back to normal. And so it's just the number of particles per cubic centimeter is that population, okay? So now notice it gave me that 7 times 10 to the 3, right? I can do something really cool in this menu with this exponential prescale, okay? I'm gonna scale the data back by a factor of 1,000. So this is just like doing dimensional analysis. So if I wanna scale that 10 to the 3, if I wanna get rid of that in the graph, I'm gonna make this -3, and notice how it went away. So my scale is only 0 to 7. And then now what I can go do here on my label options, or excuse me, my axis label, is tell my audience that this is population and units of number per cubic centimeter times 10 superscript to the power 3. Okay? And so now, look, the way that that would get interpreted is this number 6 or whatever, the peak of this data is 6 times 10 to the 3 particles per cubic centimeter. Okay, so this is a really cool way you can do unit analysis within your graph, or make it just look a little bit nicer. Okay, continuing on. Oh yes, and one thing I forgot. When we have a bunch of formatting like this, so notice I'm going to scale this up and make it 14. I'm also going to make it bold. So notice what happens here is because I use that normal, I don't know how to get rid of the superscript, but make it go back to the font size like that. So if I get rid of that /m, you notice now everything stays in the superscript. So I like to say /m, but then I have to say /z14 again, unless some of you figure out a way to keep that return there. This works. I can see a preview of how it's going to look. Okay. And that's nanometers for this scale. That looks good to me. Do it. And remember, this is still data. Has to be data points. Always data points for data. Let's go like purple, markers, triangles. I like this stroke color. What that stroke color does is put like a black line or whatever the stroke color is. It draws a line around that. And let's make it like 5 or something. Those are a little too big. So let's make it 4. Beautiful. Okay. Nanoparticle data is done. Let's do kinetic data. Window, new graph. Okay. OH exposure is the x-axis. And the normalized squalane concentration is the y-axis. Do it. Let's make a 3x3 box. And now I'm going to play with these axes, okay, and make it look nice. Okay, I'm going to pause it. Here's another great place to use scientific notation, because you may have noticed my OH exposure, like they're big giant numbers, right? Times 10 to the 11th or whatever. So check it out. I'm going to go scientific. So engineering notation is weird. Like, you know, they say 10 times 10 to the 12th, but notice scientific, it goes 1 times 10 to the 13. I don't know, whatever. Okay. And notice that that number is gigantic. So I don't have to use the high trip. Well, it's already using the high trip because 10 to the 13 is much bigger than 10,000. But now because I have that times 10, 13, on this exponential prescale, I'm going to make it minus 13. Okay? And that doesn't go away yet until I add a label. So on the bottom there, as soon as I start typing OH exposure, that times 10, 13 went away. And so now the only way that your audience is going to know, or that your reader is going to know what that scale is on this label, you need to say times 10, it's slash S 13. So it's scaled up times 10 to the 13. And technically the units of exposure are seconds, molecules per cubic centimeter. We're going to learn that in our kinetics section soon enough. So I can interpret that units as seconds times molecules per cubic centimeter. So you can see that we'll be able to tease out a rate constant out of this data later on in the semester. Okay, let's go back to some LCD sound system. Bold, 14 font, beautiful. Left axis. So this is kinetic data. So I'm going to say it's bracket, squalane, at time t, back to normal, divided by the initial squalane concentration. So again, we'll talk about this kinetic data, later on in the semester. Okay, so let's make that a little bit bigger. Let's make that bold, and then you'll notice that like after that subscript for the T, for whatever reason, it doesn't go back to the normal size. I can't figure out why that is. It drives me crazy. And here's another good example. Look at this crazy big gap. Like I could drive a truck through that margin. I don't need a gigantic margin like that. So that's where I like to go to this label options, and now just with the left axis selected, because I'm pretty happy with the bottom axis, I'm going to do that axis absolute, and I'm just going to play with the numbers. Like 10, that's not enough. 20, let's go back to like my magic number 50. Yes, that looks so much better, right? Nice and tight. And let's do the same thing to the bottom one, maybe 40. Yeah, maybe 45, sure. That looks good. Okay, and then now my axis range, I like to blow my axis range just a little past the auto scale. So that says 1.2. but I'm going to go like, or 1.12. I'm going to make it like a full 1.2. And I got a data point right there at 0, and I don't know if I'm going to be able to see it well. So I'm going to say negative 0.1 e positive 13. And notice what it did. It gave me that offset. And I like starting a scale like that with kinetic data. I like that 0 point kind of standing off a little bit. That's just my own anal retentiveness, okay? You're going to find your own style in making figures. And then left, like, yeah, I'm going to go up to maybe 1.1, and I'm going to say negative 0.1. And, you know, I just like the way that looks. Maybe you don't. Maybe you do. Okay, do it. And then now I'm going to make data points. This time, let's go green, markers, this little crazy hourglass shape. Sure. Stroke color. Okay, great. Do it. And now, what I also want to point out, on the squalane data as well as the relative humidity data, I forgot to put that in, there's error bars. So all of this data I'm sharing with you, by the way, is data that I've collected. So there was an error associated with each squalane measurement. And check it out. It also is a wave with the same number of data points. So I'm going to go back to this thing. I'm going to double click. And notice I have this option for error bars. Okay, this is sweet. I'm going to say error bars. And the error bars I have are in the Y dimension. It was in the determination of the squalane concentration. So I'm going to say plus minus wave. And I'm going to select that wave. That wave is called, you can see it right there, error underscore SQ. Okay, great. So, and then it says the Y minus is the same as the Y plus, right? Plus or minus. I'm going to say stroke color because that gives me that nice dark line. And I'm going to make these 2 so they're a little thicker. And okay, and do it. And yeah, there's some error bars. That looks great. And let's put the error bars on the voltage measurement too. So we'll say error bars. And because the error is in the voltage and the voltage is on the X scale, I'm going to put error bars on the X scale, plus minus error voltage, same to stroke color. I think these error bars are really small. Yep, you can see they're pretty small, but all the same, they're there. Oh, for some reason my minor ticks didn't show up on the voltage as well. So let's maybe, oh, there we go. So sometimes you just have to play with things, okay? Okay, last I'm going to do the thermodynamic data, okay? Window, new graph. And that's going to be, oh, I can't remember. Let's check my cheat sheet. CP, heat capacity on the Y, temperature on the X. Okay. T and CP. Do it. Here we go. Make a 3x3 box. Okay, let's get in here and do all of these axes. Okay. And that's units of joules per mole per Kelvin. Oh my God, that was on the bottom. Look at all that work I did. Okay, don't fret. Here's what I can do. I can select all of this. I'm going to hit Control X, go to left, and Control V. Beautiful. There we go. And now on the bottom, that is temperature in Kelvin. And I'm going to make that 14. Beautiful. And then let's make that range. I'm going to make the range from 0 to maybe 220. And on the left, I'm going to make it 0 to like 300. Nice and even there. Okay, great. That looks good. And then now data points. Always data points for data. This time, let's go hot pink. Markers. Sideways triangle thing, sure. Do it. That looks great. That looks kind of like an arrow pointing up. Cool. Okay, now I'm ready to make this final layout, so I can say Windows, New Layout. I'm going to select all those graphs, hold the Command button down for Mac or Control for PC. So graph 3, or graph 2, graph 3, graph 4, graph 5, do it. And I got to zoom in a little bit so I can see. Okay, and that's awesome. And so here is where you notice this is now why these publishers give you the option for a 3x3 figure, because when you build in the margins of a standard like paper, and then you have two 3x3 figures next to each other, they fill out a page really nicely. So I'm going to take this, I'm going to put it like, I can have that box go a little past the margins, because I just want the graph to be outside of the margins. Okay? I'm going to say convert to embedded, and I'm going to get rid of that frame. And then now with this graph, I can bring it in there, and look, as I'm holding it down, I can like line it up with the other graph to make sure it's nice and square. That looks cool. Okay, convert to embedded. Frame style none. Same over here. Let's make this one line up kind of nicely. Make sure it's all outside of the margins. Okay, convert to embedded. Frame style none. And then now finally, hopefully I've got enough. Oh, look at this. See? Okay. This is why that axis absolute thing is important, because watch what happens when I put this one on here. Convert. Look, that label, right? I didn't give myself enough space in that label, okay? So the way I can do that, because I haven't, I've converted all of these, right? Notice I can't move them. So what I have to do is click back to it and say convert to graph and object. Now it gives me the ability to fool around with this thing, okay? Oh my God, what did I do? Oh, there it is. Okay, and then now I need to convert this one back to a graph and object so I can get it out of the way. And I'm going to try to just reorder this one. I'm just going to put it on this side because maybe that'll fit a little bit better. Yeah, that looks pretty good. Get rid of that frame. Okay, so I got to do some editing on that thing. So now I'm going to go back to that graph. Here it is. I'm going to get that label a little bit closer in from the label options on the left. Axis absolute. Let's make it nice and tight. Yeah, that looks great. It also looks like, did I do a bold? Yeah, I did a bold. Okay, do it. So now that's nice and tight. I'm going to say, yeah, let's get it right there. Convert to graph and, oops, I did it backwards. Embedded. Frame style none. I think I maybe accidentally reconverted this, so embedded. Frame style none. And look at that, I got 4 graphs on a page, and now you can do really slick stuff, right? By saying like, okay, put this caption on there. And I can call this figure A, Z, I'm going to make it just maybe let's make it like 18 font. Okay, do it. And I can put that, select the cursor, and I can put that like in that caption, figure A, figure B, figure C, figure D, right? So finish it off for yourself so you can kind of see what I did here. I labeled it, export it, and then at the end of that PDF document that has the instructions, I'll give you instructions on how to finish this assignment. Okay, folks, happy Igoring.